We're going to look at how to do the center of mass calculations in positive physics. So if you look here, we have a 10 kilogram object and a 20 kilogram object. So we're looking for the center of mass of this system. So over here, you're going to fill out the information that we know. So we know that for A, it is 10 kilograms, and it is located at 2 over and 3 up. So the x-coordinate is going to be 2, and the y-coordinate is going to be 3, and that's for A. And then if you look at B, the center of mass of just object B, it's 20 kilograms. The x-coordinate is at 1, 2, 3, 4, 5, and it is also at 3 up. And so then for the center of mass of the system, the mass of the system is 30. The x-coordinate of the center of mass of the system, we're going to have to figure this one out, but the y-coordinate is still going to be 3. It doesn't have any difference in its vertical. So for the x-coordinate of the center of mass of the system, you're going to use the equation, and the equation is that the position of the center of mass is the mass times the position of the first object plus the mass times the position of the second object for however many objects you have. So, and then you're going to divide by the total mass of the system. So for this one, we're going to have x of the center of mass is going to be the mass, which is 10, times its position, and I'm just doing the x position, which is 2, plus the second object, B, which has a mass of 20, times its position of 5. And I'm going to divide that by the total mass of the system, which is 30. And when I plug that into my calculator, I'm going to get 20 plus 100 over 30, which is going to be 4. So the center of mass of the system is going to be at 4.0. The x-coordinates of the center of mass of the system, it's these two here. So 4, and then the y-coordinate is going to be 3. And that's done. If you have 3 objects, it just means you're going to have a little bit more to do. So for 3 objects, object A has a mass of 60. The x-coordinate here is going to be 2, and the y-coordinate is up 3. I've checked, and these are all just 1. So this is going to be 2, 3. For B, it has a mass of 25, and it is at 5, 2. So 25, and it is at 5, 2. And C has a mass of 40, and it is at 2, 4, 6, 8, 3, 4, 5, 6, 6. So it's at 8, 6. Okay, the total mass of the system is going to be 125. I just added those up. Now, since we have different x-coordinates for everything and different y-coordinates, we're going to have to do what we did in the last one, but for both of the coordinate planes. So I'm going to find the center of mass for the x-coordinates. So the center of mass is going to be the mass times the position of the first object. So 60, and I'm using its x position. $60 times 2 plus the second object, which is going to be 25 times 5, plus the third object in this one, which is going to be 40 times 8. I'm going to divide that by the total mass of the system, which is going to be 60 plus 25 plus 40, which I already figured out was 125. 125. So my center of mass in the x direction put it in my calculator. It's going to be 120 plus 125 plus 320, and all of that's divided by 125. So 4.52. So this is going to be 4.52. And then for the y direction, y center of mass, I'm going to have the same thing. I'm just going to use the y position instead. So it's going to be 60 times 3 plus 25 times 2 plus 40 times 6. And again, I'm going to divide that by the total mass of the system, which is 125. And my center of mass in the y direction is going to be 180 plus 50 plus 240, all divided by 125, which is going to be 3.76. So 3.76. Now, if I put that on the graph, which I don't have to, but I'm just going to look at it and see if it makes sense. So x is going to be at 4.52, so 4.5, and 3.76, 1, 2, 3. So it's going to be about right here. So if I think about that, this is 40 for C. A and B together are quite a bit heavier than 40 is. So that makes sense that it would be shifted, the center of mass of the system would be shifted towards A and B and closer over there, because this is 85, and this is about 2/3 of the way along. And it would make sense that it is kind of shifted in from the sides, from A and B, so it's more along the midpoint of that. So that makes absolute sense that the center of mass would be there. Okay, and then for this, you're just taking these two and you're just putting them there. So it's going to be 4.52, 3.76. Okay, the last type I'm not going to solve completely, but just give you an idea here. So for these shapes, they have a uniform density, and 1 kilogram per square centimeter. Well, a square centimeter is a box, so it's 1 kilogram per box. So you could count this up, and this is going to be 8 kilograms. 1, 2, 3, 4, 5, 6, 7, 8, because it's 8 boxes. And this one is 1, 2, 3, 4 times 6. So this is 24 kilograms. So that can get you your mass for your boxes. And then just thinking about what you did in the last one, the center of mass concepts, you know that since these are kind of regular shapes, the center of mass of the system it's going to be in the middle of these right there. And so you could find those x, y coordinates for each one and plug them in. And then you're going to solve it just like we did. Okay, let me know if you have any questions.